So we have seen what is mole concept, but we have not solved as many numericals as we have to understand what is a mole concept. We have solved a couple of them, but let us continue our discussion on the numericals on mole concept. So that is what we are going to do today. So for that, we have seen one or two simple problems on the last day, in the last video. So let us continue. So the first question for today is, question goes like this: how many molecules of water of hydration are present in are present in 252 milligram of oxalic acid. One thing which is given is oxalic acid, its formula is given, which is H2C2O4 and 2 molecules of water. So let us proceed. So the question that you can see, we have to solve it out. So the thing is, first of all, let us understand its molecular mass. Actually, oxalic acid is like that: CO2H bond CO2H, comma, 2 molecules of water. This is the formula of oxalic acid. Having said that, in order to calculate its molecular mass, it should be 2 into 12 plus, here it is 4 into 16 plus 2 into 1 plus 2 into water, as we already know, it is 18. So we are getting as 24 plus 64 plus 2 plus 36. So here it is, you see, 26 plus 64, we are getting 90 plus 36, that is 126 gram. Now we know that 1 molecule of oxalic acid contains 2 mole of water. So what we can say is that in 1 mole of oxalic acid, 2 molecules of water. So one mole of oxalic acid or 1 molecule of oxalic acid contains 2 molecules of water. You can say 2 mole also, whatever. So that means 126 gram of oxalic acid, if it is, it should contain, better I should write, so in this case 126 gram of oxalic acid, if it is, it will contain how much? It should be 2 mole rather, because it is 2 mole, as you can see. 1 mole contains 2 mole. So for 126 gram, it will contain, and we also know at the same point of time that 1 mole of oxalic acid is equal to 126 gram. So 126 gram of oxalic acid contains, as we know, in 1 mole there is Avogadro number, that is 6.022 into 10 to the power 23. So in 126 gram of oxalic acid, it will contain, so since it is 2 mole and 1 mole is equal to 6.022 into 10 to the power 23 number of molecules. So it should be 2 into 6.022 into 10 to the power 23 number of H2O molecules. That is the case. Now, as per the given question, it is about 252 milligram. So for 1 gram, it should be 2 into 6.022 into 10 to the power 23 divided by 126. And for this much of 252 into 10 to the power minus 3 gram, because it is in milligram, of oxalic acid contains 2 into 6.022 into 10 to the power 23 and multiplied by 252 into 10 to the power minus 3 divided by 126. As a result, we are getting the result. Actually, you should calculate this much. Whatever is the answer, that will be the case. I am just writing the answer given in the book. I am just directly writing without calculating. You should check it by doing yourself. Which is 2.4 into 10 to the power 21. This is the value which is given. You should check. So this is the first problem for today. It is 2.4 into 10 to the power 21. This is the first problem for today, and let us proceed for the next one. First you write it down. Okay, write it down. Now let us proceed for the next one. So let me readjust the screen. Now, the next problem is calculate mass of sodium which contains same number of atoms as are present in 4 gram of calcium. Atomic mass of sodium and calcium are atomic mass of sodium and calcium are 23 and 40 respectively. So that is the case. Now the answer. First of all, question is same number of atoms. It contains same number of atoms as present in 4 gram of calcium. So first of all, let us see that for calcium, what should be the situation. So we should say that if 40 gram of calcium is equal to 1 mole of calcium. So it should contain 6.022 into 10 to the power 23 atoms. So if we are talking about 4 gram, it is quite obvious. So it should be 6.022 into 10 to the power 23 divided by 40, and when it is 4, it should be 6.022 into 10 to the power 23 divided by 40 into 4 atoms. So it will be 10, and it should be 6.022 into 10 to the power 22 atoms. This is the answer. Now what we have got is, see the question carefully. Same number of atoms will be present in how much of sodium? That is the question. So it is quite obvious that, see, 6.022 into 10 to the power 23 number of sodium atom should be is equal to 1 mole of sodium. If it is 10 to the power 22, so if it is 6.022 into 10 to the power 22, it should be 1 by 10 mole of sodium, right? So if it is 1 by 10 mole of sodium, so obviously 1 mole of sodium is equal to 23 gram, and 1 by 10 mole of sodium should be 2.3 gram. So this is the answer, desired answer. Two very standard problem we have solved. I hope you have got it. So write it down. Next question is, calculate number of moles in each of the following. In this case, the first question is, in 11 gram of carbon dioxide, and the second question is 1.12 liter of carbon dioxide at STP. So first thing first, carbon dioxide, molecular mass 1 into 12 plus 2 into 16. So it should be how much? 44 gram will be the molecular mass. Now 44 gram of CO2 is equal to 1 mole of CO2. So we can also say it should be equal to 6.022 into 10 to the power 23 number of molecules. Similarly, 1 gram of carbon dioxide should be 6.022 into 10 to the power 23 divided by 44, and if it is 11 gram, it should be 6.022 into 10 to the power 23 by 44 into 11. Now obviously it is 4, so accordingly we have to calculate. To calculate this, how much you are getting? I think you will be getting, if we are calculating number of molecules, this value will give you the number of molecules, and if you are talking about moles, 44 gram is equal to 1 mole, so 11 gram should be 1 by 4, that is 0.25 moles. And obviously you can calculate this part to get the final answer. Here the question is moles, so I am not calculating, you can do it easily, only I am talking about this part. Next is about the volume. So in case of volume, we know that at STP 22.4 liter of carbon dioxide is equal to 1 mole of carbon dioxide. If it is 1 liter, it should be 1 by 22.4 mole. If it is 1.12 liter, it should be 1 into 1.12 divided by 22.4 mole. Now I think you will be able to calculate. You will be getting as this should be like, if you cancel it out, it should be 11.2 and it should be 0.56. So if you calculate this much, you will be getting around 0.05 mole. So this is the answer. Today we have seen 3 different type of problems regarding the numericals of mole concept. Now it is your duty to solve the given assignment, and accordingly, if there is any problem, reply back to me so that I can help you out.